So hello everybody, and welcome to today's webinar presentation, 5 product use cases and design patterns for data apps, brought to you by Snowflake. I would like to introduce you to our presenter, Kevin McGinley. Kevin is currently a technical director on Snowflake's customer acceleration team, focused on helping customers adopt Snowflake into their application and data platform architectures. In this role, he spent a lot of time advising companies building data applications on top of Snowflake and integrating their needs into the Snowflake product roadmap. So now I'd like to pass it off to Kevin for the presentation.
Awesome. Thank you very much. Appreciate that introduction. And hi, everyone. Like Drew said, my name is Kevin McGinley. I'm part of our product org at Snowflake. And I'm going to walk you through, some typical use cases for application development and what those sort of design patterns look like for those data applications. And so whether you're someone who's a startup or whether you're an established software vendor, probably at the core of today's modern application for you is a large volume of complex data that changes rapidly. So I'm going to kind of walk you through what some of those design patterns are and use cases are for those design patterns, and I'll talk about how Snowflake is helping our customers solve some of the challenges that come with those design patterns. So first, to just sort of level set everybody, for those of you who may not be familiar with Snowflake or know what Snowflake's all about, we currently have over 3,000 customers of all shapes and sizes, from startups to Fortune 100 companies across many different industries like financial services, healthcare, retail, manufacturing, and more. Some of those customers initially looked at Snowflake for some of their internal, data lake, data reporting, and data warehousing needs, while others were, application developers who already had an application in place, but were, sort of dissatisfied with the stack that they were running their application on. And I'll talk to some of the reasons why they had those challenges. So the bottom line is that, there are many reasons why you would choose, Snowflake for your data platform, whether it's for data lake workloads, data engineering workloads, data warehousing, sharing your data with your customers and partners. But today we're going to focus on sort of the data application use case in Snowflake and how that plays out across our customer base. So to level set everyone on Snowflake and its architecture, because it's kind of important to understand this in case you're not familiar with it, to sort of understand how our customers are sort of addressing some of the challenges across their data application use case. Let me just do a quick run through of how the Snowflake architecture works. So Snowflake is a managed service that's built on top of the public cloud providers that you see there. We run on the 3 primary public cloud providers, GCP, AWS, and Azure. And we use their core common infrastructure pieces under the covers. So their object store, their compute, their networking, their security and key management services. And then we've added our own secret sauce into the Snowflake stack for it to be a highly scalable data platform for the cloud, built from the ground up by our founders who are coming from the Oracle relational database world and other areas of using relational databases over the years. And so they're very knowledgeable and have deep understanding of how to build a database. And so they decided to build one on scratch that runs in the cloud. And the core sort of architectural decision that they made, which the cloud enabled for them, was to separate storage and compute. So at the core of Snowflake's architecture is the fact that we separate those two components. We run our centralized storage on the cloud object store. We run our compute on the cloud compute, and we make those separate and interchangeable from a scalability standpoint, which really benefits our data application customers. So from a storage perspective, we're managing all of the file management under the covers. We have a file format that's highly compressible as well as fast query performance. We manage the encryption of those files for you. We manage the redundancy of those files for you. All of that is done at our centralized storage tier. And to you, you see databases, schemas, tables, just like working in any other relational database. Our compute layer is, we call it our multi-cluster compute because it's highly elastic. So as you would imagine and expect for the cloud, the compute is highly scalable, meaning that we can scale both vertically for faster query performance, and that's increasing the size of a compute cluster. And we can scale horizontally for concurrency, which equates to running multiple copies of the same compute cluster to handle more users on the system. And it's this scalability that our application developers cite as one of the primary reasons why they either choose Snowflake from the get-go, or it's the reason that they choose to move to Snowflake for their data application, because they typically run into some of those typical concurrency and scalability problems in some of their other data storage choices. And then that outer ring that you see in the Snowflake architecture is sort of the secret sauce that we bring to the table. So Snowflake under the covers is a managed service. So we have transaction management where we're treating immutable cloud storage like an ACID compliant relational database. We have a metadata layer which keeps track of all of the storage elements and keeps track of them over time and creates a logical representation of everything instead of a physical representation of everything. Our query optimization makes our queries fast. Our management layer will help automate the things like spinning up compute, spinning down compute, automatically horizontally scaling compute. All of that is automatic and built in for you. And lastly, it also includes our sharing and collaboration feature where you can grant access to data sets within your Snowflake account to other Snowflake accounts, just as if those databases were inside those consumer accounts. So this is what sort of makes our architecture unique and interesting for data app builders, and I'll talk a little bit about why that is. But first, a little bit about the sort of different workloads that we facilitate for customers, because this kind of plays into how companies get to sort of building data applications on Snowflake. So we started off as a cloud data warehouse. Data warehouse built for the cloud used to be our sort of marketing slogan, and so a lot of companies know us with the ability to handle analytics at scale. And that typically was done from an internal perspective, internal reporting for customers, just like you would see in a normal sort of data warehouse environment. And then the other workloads sprung up around it because it became clear to our customers that, once they started bringing a lot of data into Snowflake for their data warehouse, they realized, oh, well, based on some other Snowflake features that I'll talk about, they could also take a data lake design paradigm and implement the typical things that you do in data lake design within inside Snowflake as well. Even though we were a relational database and you typically don't do that data lake design on a relational database, we behave differently than other relational databases in that regard and facilitate that feature. And once you're starting to implement a data lake design paradigm, it's really important that you have all the data engineering capabilities that go with starting with a data lake and curating and integrating and standardizing into a data warehouse model. So our customers were heavily involved in the ELT pipelines that help to transform the data into the state that it needs to be in. And then once customers had that, they realized, well, hey, all of our data scientists want access to one central repository for large, vast amounts of data. Let's bring those teams onto Snowflake as well, so they can do all of their feature engineering with the data pipeline features. They can train and test models, and then even deployed models can call, data that's coming into Snowflake can reach out to those trained models and perform, predictions on the fly, et cetera. And that's where our data application customers come in, because some of them realized, wow, gosh, I need to build this data application. All the data is already in Snowflake. Rather than offload this to another data store, why don't I actually build the data application on Snowflake? Or for our customers that came to Snowflake, without having any other workloads, they realized that some of the reasons why Snowflake is chosen for those 4 other workloads on the left are similar reasons why they would choose Snowflake for a data application, even though that's not how we were sort of marketing ourselves. And then lastly, our data application customers, as well as our other customers, realize that, hey, it's really convenient once I have all this data in Snowflake to be able to share it out to my business partners, my customers, without actually having to move the data out of my account to do that, or set up complex APIs or FTP servers to have my customers and partners get at that data. And that's where our data exchange feature comes in. So those are the workloads that we satisfy within Snowflake. Let's now drill into the data application space and spend the rest of our time on that. So what do we mean by data apps? Well, I've been in this space for 25 years, and to me, an application, I kind of immediately think of the sort of heyday of applications and like big ERP applications that were designed around how to help humans transact business processes within an organization. And all organizations have a lot of common business processes that they have to execute on and that they have to transact. And ERPs were good applications and collections of applications to help facilitate and make all that possible. But somewhere along the line, and we'll say, sort of a huge rise of internet and social media and SaaS applications, data apps became more complex, data-driven, less about sort of relying on capturing individual transactions, but more about capturing large volumes of data from non-traditional sources. And there are all kinds of reasons that these data apps exploded, but what really comes down to is that what we used to think of as an application is not really what today's application is. And in a way, every application today is becoming a data app, because every application need has this sort of need for this large volume of data to perform its function. That's becoming somewhat of the norm in the technology space. So as we look at, why then do customers turn to Snowflake to build these data applications, there are sort of 3 primary reasons for that. One is as I mentioned before, are sort of unlimited scalability and concurrency. And by that I mean I can scale my storage independently from my compute if I need to. I can scale my compute independently from my storage if I need to. If I need to spin up many compute nodes to do different workloads and isolate those workloads onto different compute nodes so that they don't collide with each other, I can do that. If I need to have a compute node that can automatically expand itself to handle more when more users are on the system, and contract itself when users are no longer on the system, that's incredibly important too. So that scalability feature is one of the huge reasons why our data application customers choose us. The next reason is, even though we're dealing with large volumes of data, SQL is still the sort of standard language that everybody knows to interact with data. And actually having ANSI compliant SQL that is transactionally consistent, ACID compliant, is a huge need. And we kind of learned this from going to some of the other database platforms that people have sort of toyed with over the last 10 years. And it became really important in a number of application needs that we still have that sort of rich SQL capability, rather than having to learn all new languages from scratch. Makes it harder to sort of manage and deploy your application, as well as still be able to work in a database like you're working with a database, just at larger scales, which older traditional relational databases had a hard time with because they weren't designed for that scale. Snowflake was. And then lastly, with Snowflake being a managed service, there's a lot of fundamentals that are offloaded to the managed service component of Snowflake. Managing your sort of backups across availability zones within the cloud, making sure that you have compute running in multiple data centers in case a data center goes down, being able to actually run in different clouds simultaneously. is something that you can do with Snowflake, as well as some other features that we've just built into the product that you don't have to worry about anymore. And so what that means is that our data application customers can spend more time building their application rather than having to sort of manage infrastructure to to support the application. So that's a huge benefit for them. So let's dive into what some of the common use cases that we see are, and what some of the reference architectures look like for those use cases, and where Snowflake fits into that. So the first one is Customer 360. This is a pretty sort of generic term in a way, but it really involves, how can I better understand my customers and engage with my customers? And we'll talk about why that has sort of exploded in not only significance, but in complexity as well. The next is the Internet of Things. So we now have, instead of humans sitting at keyboards generating transactions, we now have devices generating transactions. And those devices are generating transactions at scales that humans never could. And so there's a whole host of challenges that come into play whenever you're dealing with an application that has at its source, machines instead of humans. Machine learning and data science, that's a pretty generic and broad topic, but what it really means is that applications now have to do way more than they ever did in terms of, just instead of recording transactions and presenting them back, and maybe presenting them back in an aggregated fashion, they now have to do more sophisticated analytics. They now have to predict things, they have to segment things, they have to cluster things, they have to do more advanced analytics than what was sort of typically asked of them in the past. And that comes with a whole host of challenges as well. Application health and security analytics, that's been around for a long time, but it's become increasingly harder as the technology footprint of an organization just keeps expanding and expanding. As we rely more on technology for fundamentals in running a business, the more we need to understand how is all of that behaving, what is the health of it, is it optimized, and from a security standpoint, are our internal people doing the things we want them to do in the way we want them to do it? Are our external, people accessing things the way they need to, and are we blocking the people we don't want to have access to things? All of that is important, and more important now more than ever. And then lastly, embedded analytics. This kind of is the bread and butter of sort of a data application, but this is becoming even harder and harder to do at scale. And we'll dive more into this notion of, I've already got an application, but I need to provide sort of like a reporting as a service or data warehouse as a service alongside that application. How do I do that? So let's dive into each one of these. I'll kind of talk through each one in a little bit more detail, as well as walk through a reference architecture for each one, and we'll see how Snowflake fits in. So when we think about Customer 360, again, this is all about capturing information about your customer. And years ago, that sort of was, there were a few core applications that would have information about your customer. But nowadays, there's so many more places that we need to get customer data from. And our sales and marketing teams need that data to have a complete view of how we as a company are engaging with our customers. They need to do this to understand customer behaviors and patterns and unveil new customer segments. They need to be able to target customers in very specific ways through emails, push notifications, inside applications, through chatbots, et cetera. And ultimately, this sort of goal hasn't changed. We ultimately want to try to figure out, how can we optimize what a customer is willing and open to, sort of engaging with us from a business relationship perspective? How can we sell them additional things that are like the things that they're already getting? How can we give them more advanced versions of the things they like if they're willing to pay more money for it? So uncovering those things are really important within a Customer 360 data application. However, the challenge, as I mentioned, the data is now more fragmented than ever. Whether you're having to look out to social media, or whether you're having to get, from Wi-Fi hotspots in a retail store, get traffic patterns from customers in terms of what they're doing when they're on the Wi-Fi in the store, or where they're walking around in the store through RFID sensors, or maybe you've got data that's coming in from your website in clickstream fashion. All of that data is highly fragmented, and unfortunately, it doesn't all conform to a nice consistent structure. Many of the sources are semi-structured in nature, which is much harder to deal with. They don't have a consistent structure. Even within the source itself, different types of events don't have a consistent structure. So dealing with all of that structural complexity in the data is definitely a challenge within Customer 360. And then sometimes the data is not even under your control. You need to get that data from a third-party service, whether it's because that third party is in the business of engaging with customers in ways that you cannot, or whether it's because that third party has done some very sophisticated analysis around a certain aspect of the data that you need to get at, and you need their insights to pair with your own. So let's look at the reference architecture behind this. So there's a lot of boxes and arrows on here, just like any reference architecture typically has. So let's kind of dive into the different parts that I want to emphasize. So the first is that it's becoming more and more common to use certain sort of streaming platforms, whether it's Kafka or Kinesis or Cloud Pub Sub or Event Hub, to get data to locations that need them. And Snowflake is well positioned to grab data from those open streaming platforms. So this can be a great way to get data into your Snowflake platform, to get data in as timely a fashion as possible. Near real time is the ultimate goal, so that you can do things as data comes in based on engagements that you're having with your customers. And you can handle data sets that are not easy to facilitate through sort of traditional structured methods. And that kind of goes to our native semi-structured support, most commonly in the form of JSON in the data application space, although we extend into other semi-structured formats. But ultimately, this is the ability to ingest that semi-structured data natively, without having to parse it first into any kind of structure. Snowflake does that behind the scenes for you, columnarizes all of the arrays, and then gives you a SQL syntax to be able to query that natively ingested semi-structured data without having to transform or parse it first. So you can grab that native data, load it into a table. Yes, that sounds counterintuitive for any people working on big data platforms out there, but we have a nice data type called variant, where all you have to do is define one column in your table, and you don't have to define a schema from there. You can load entire JSON arrays into that column and do schema on read versus schema on write. So that capability is incredibly valuable for our data application builders, because it helps to minimize how much they have to manage that. Additionally, if there's some data sets that you don't want to ingest for whatever reason, we offer external tables that can point to all of the cloud storage services, where you just have the table structure in Snowflake and you can run queries against the files that are in your object store. You can combine those external tables with internal tables as well. So they act and behave just like regular tables, but the data doesn't sit and live in Snowflake. And this can be incredibly valuable if you're not ready to bring in a certain data set into Snowflake, or maybe the data volume is such that you don't want to bring it in, or for whatever reason it's data that needs to stay resident in the place where it lands. We have that capability to reach out and still query and manage that data within the Snowflake environment. And that can then be used as one of the sources, along with our data sharing feature, for you to combine and enrich third-party data together with your streaming data, with your data that sits out in object store. That data sharing allows you to point out to a data provider's data set without actually ingesting that data into your account, but you can still run queries against it, similar to the external table, except the external location now is another provider's Snowflake account. And you're able to run streams and tasks against all of that to enrich that data and produce new table outputs within your Snowflake account that you can use for analysis in your Customer 360 application. And then ultimately, as all of this data is coming in, you can have external functions within Snowflake that reach out and call machine learning models. So as data comes in, you can call out to these external services to pass data from Snowflake to it to make things like recommendations that can be then used and fed into your application. So that as customers are engaging with your application, you can use your ML models to drive some of their behavior in the platform. So all of this is possible within this Customer 360 reference architecture, and hopefully that gives you a good idea of how Snowflake fits. Oh, and lastly, sorry, forgot that, as you're storing all of this data, the benefits here are that, we're using very cheap commodity object storage behind the scenes. So $23 per compressed terabyte per month means you can store all of the data you need without worrying about that data scalability. So let's move on to IoT, because that element is really important in an IoT application. And as you think about an IoT application, again, this kind of comes down to, hey, this is no longer about humans and machines doing things. It's about monitors and sensors. That could be health devices. It could be vehicle devices on fleets of trucks or construction equipment. It could be RFID sensors that are detecting people movement and traffic patterns. It could be sensors on equipment within the energy industry. So whether you're talking about oil wells, or whether you're talking about an electric grid, or gas sensors, all of those use cases come up within an IoT data application. And so we want to be able to grab all that sensor data, bring it into an environment. We want to be able to analyze it to predict things like failures and maintenance schedules, and whether or not certain things are optimized to routes or temperatures, or sort of revolutions per minute, depending on what it is. And that will allow us to sort of analyze both from a historical perspective as well as predict what's sort of possible there. The challenges, of course, though, as I mentioned, are data volume is overwhelming, even more so overwhelming than in the first use case. And it's incredibly costly to store, although, as I just mentioned, because Snowflake is using commodity object store at a highly compressed level, we're actually able to significantly reduce the cost of storing all that data. And a lot of it, in fact, all of it, for the most part, comes in a semi-structured data. So we've got to be able to handle arrays and JSON in a way that doesn't disrupt our ingestion process, nor prevents us or has us spending a lot of time having to process that data for usability. And so ultimately, if data is coming through in a manner that gets disruptive for any reason, we need resiliency in our ingestion processes to be able to handle that. So what's the reference architecture for this look like? Well, the first thing to point out here is, we still have our easy ingestion mechanisms through typical sort of open source and common cloud service frameworks, especially for streaming ingestion. It's very common nowadays to sort of pair IoT message brokers with these streaming services, and we can ingest the data from those services in the same way that we discussed in the Customer 360, but even at significantly higher volumes and rates than we saw before, because of the nature of IoT data. From there, again, our ability to ingest that in its native semi-structured format, land it into a schemaless table, but then immediately start writing SQL on top of it to be able to query that data without having to go through any kind of parsing exercise, is incredibly valuable. So that's huge in terms of being able to take action on this data as quickly as possible. And that action is typically involves some sort of time series analysis. And the great news is that Snowflake ingestion is optimized for time series analysis. In fact, while you wouldn't necessarily classify us as a time series database, a lot of what our customers do from an IoT application perspective is time series centric. And we do an excellent job of, in a relational database platform, doing typical time series optimized queries. You can use our streams and tasks feature to aggregate that data. More often than not, when you're presenting IoT data or doing analysis on IoT data, you have to roll it up to a level of granularity that's more digestible. And we have automated task features that you can schedule and have run at intervals, or run when it sees new data in a stream. To actually pre-aggregate all that data out for your analytics use cases within your IoT application, as well as still use that external table functionality to be able to query out to things that you do land in Object Store but choose not to bring into Snowflake. And so lastly, as I mentioned before, the ability to store all of this IoT data at commodity prices, for storage is incredibly valuable, which is also valuable for the app health and security analytics use case. And as I mentioned before, this is kind of like the first IoT use case there ever was, in a way, because we've been ingesting application log data, operating system log data, networking log data within IT for many years now. The challenge is that this has become much more, a much higher scale than it used to be. And now with the sort of introduction of the public cloud, there becomes many more places that you need to gather this data from. And so, with that, being able to have ML models that can predict threats, reduce our security operation response times by automating our detections instead of having, people looking for those, being able to look for places where we could optimize our application health, or where we could detect that we have vulnerabilities. These are all the types of things that we're looking for in this type of application use case. Some of the key challenges of this, of course, is all the different connectors that you have to go out to get all this data from. So ingesting this data in real time is definitely challenging in terms of all the different places you have to get it from. And storing large volumes of data is incredibly costly. There are applications and companies that are dedicated to helping IT manage, this sort of application space. They're known as SIMs. But unfortunately, storing large volumes in a SIM is incredibly expensive. So we'll talk about how we can complement that. And as well, your time to insight is important here. So any way in which we can speed that up is incredibly valuable. All right, so let's look at the reference architecture for this use case. So, more boxes and lines here, and some new boxes that we haven't seen before. But again, it all starts with our ability to ingest data easily and simply. And so this is a good time to really emphasize our Snowpipe feature, which is a serverless ingest engine that has an auto ingest feature, so that it can watch for notifications across all the different places that you might have, that you might land data from your different application health and security systems. And Snowpipe can be set to automatically grab that data and pull it into Snowflake, all without having to manage any kind of servers to do so. So that Snowpipe auto ingest is incredibly valuable within this app health and security analytics use case. Again, our ability to run tasks on a schedule or on an interval allows us to call SQL statements or run complex stored procedures that will look for data coming in and try to detect certain things that we want to generate alerts on. And so the fact that you can create those ahead of time and then just have those constantly run within the system, checking for certain things, the occurrence of certain things, using our Snow Alert framework is incredibly valuable. That Snow Alert framework is an open source framework that we publish out on GitHub, and that has the combination of sort of two things. It's how do I set up a sort of rule engine that will look at all the different sources that I have coming in and run those queries to detect the things that I'm interested in detecting. But how can I also push out those alerts when it detects something to some sort of messaging service, whether that be something that's going to generate an email or a push notification, or it could also be something that generates a ticket in something like Jira that allows someone to take action on something that was found. And what's really important there is when they need to take action, oftentimes there's analysis that needs to be done that requires looking back in time, to really figure out what was the cause. Let's take let's say a threat detection, an intrusion detection was found with the rule engine. Well, what is that uh, you know, uh, intrusion all about? How did that come to be? Where can we see whether there were attempts to get in, but they couldn't get in, but they eventually did find their way in through another method? Can we trace back what those patterns were like? And that requires more than just a short-term amount of history, which is what's typically kept in the SIM products that you see on the right there. So Snowflake introduces an opportunity here to store a year or more worth of history of all of these logs so that you can go back and research, what was the sort of pattern of behavior that led to this downtime or that led to this intrusion. All of that can be more effective and cost effective to store versus storing it over in a SIM. And again, though, what we want to call out here is that we're not necessarily trying to replace the SIM. There's lots of functionality that's built into the SIM that maybe you don't want to try to add into Snowflake that's sort of not there naturally. So you can complement Snowflake with your SIM if you want. You can use your SIM for that sort of short-term storage to do some of the things that they're designed to do natively that Snowflake doesn't, and then offload the data from the SIM. You could reverse that arrow going the other direction if you want. To Snowflake, or you could have the data go into the SIM from Snowflake as well, your choice. That arrow could go both directions if you need it to. Ideally, though, what you're able to do here is sort of complement the SIM functionality with the sort of long-term storage capability of Snowflake and the ability to do all that rich analysis. Moving over to the ML and data science applications, again, this is all based on trying to do more advanced things within your application. Make recommendations based on transaction history, predict things based on different readings from like an IoT perspective. How can we cluster our customers in our customer 360 example better based on things that aren't obvious that we can't tell using more sophisticated analytical means? How can we detect malicious behavior based on security logs? Ultimately, all of this is the more advanced analytics that we're trying to build into our applications. But the challenges are that these models need to be built on large volumes of clean data, and so there's a lot of data engineering that goes into the machine learning building process. In fact, that's a huge portion of the work, is just collecting, gathering all the data and cleaning it up and enriching it in the way that it needs to be done. Or if that's already been done, taking a copy of that data because you need to provide an additional level of enrichment on top of it, or you need to transform it in another way that it's currently not sitting in a production environment. And now we're creating all kinds of duplicate copies of the data, which doesn't make sense to do. And because these workloads are more resource intensive, we end up over provisioning on the resources required to do these computations, when in reality we need something that's more elastic, that can run the workload and then kind of shut itself down and go away and not be billed for it. So what does an architecture look like in this example? Well, ultimately it starts with what I mentioned before about sort of taking a copy of already pre-existing clean data. we have a feature in Snowflake called zero copy clone, which allows us to take a logical copy of data instead of a physical one. And that logical copy becomes a real data object that we can operate on in the same way that we normally would. We can update the data, we can add new columns, we can add new rows, all without actually taking extra copies of the data to do it. So I can start as a data scientist by taking a zero copy clone of an existing data set and then enriching it further. And I can do those enrichments. I can standardize them, run them with streams and tasks, or I can do them as one-off enrichments and discard them later. Either is possible. And if I need to potentially incorporate another data set that I'm not sure of its viability or whether it's definitely going to be part of the data that feeds my model, I can build external tables pointing to that data in object store instead of having to go through IT or some other part of the organization to first load that data into Snowflake. I can just quickly point some external tables that points to those file locations, do my sort of investigation as to whether that data is useful and valuable, and then ultimately decide to bring it into Snowflake if it's going to be meaningful through our materialized view feature over top of external tables. That leads then to using a rich, extensive library that data scientists are used to using, whether that's programming in Spark or Python, and calling out to model services and training platforms and machine learning libraries that are all sort of standard in the industry. I can use those with my Snowflake connectors and drivers that lets me operate in the sort of programming languages and libraries that I'm used to while still getting all of my data from Snowflake. And then from there, as I've deployed my finished models out to sort of a production environment, as new data comes into Snowflake, I can make that external function call out to my model with a data set that has recently come in, and run a prediction on that data set or enrich it with new attribution or segmentation as the data arrives in Snowflake. So all of that is possible in this reference architecture. And then lastly, from an embedded analytics data application perspective, these are all about, hey, I've got another application that's performing some sort of business process, and maybe I'm the company that runs that application, and I want to provide my customers with an embedded analytics service, or maybe I'm building an embedded analytics service on top of a more commonly offered SaaS provider. We have customers that do that as well. But ultimately, what you're trying to do is deliver that sort of first-class insight within the context of the application. So I don't have to go out to some external reporting system to go run a report, look at some numbers, then come back over to the application. I want to be able to see those sort of descriptive analytics right within the context of the thing that I'm looking at within the application. And that allows me to then sort of drill deeper into what is it that I'm looking at, what is it that I'm trying to do. I can actually pass the context of the application into my analytics to give me insight on what's there. And ultimately, if the two are tightly coupled together, ideally then, I'm getting as close to near real-time updates on those embedded analytics as possible. The problem is that, as more and more users come on the system, the performance suffers. And this is even more challenging in an embedded analytics environment than it is in your own internal environment, because at least within your own internal environment, you have some degree of influence on when the application is available, and you can truly see the patterns of when your users are going to use the system, and you can go talk to those users to understand when they're going to use the system. When you've got a larger scale of external customers around the world coming in at all kinds of crazy times, it's much harder to understand those sort of performance spikes, and as a result you tend to over provision, which hurts your product margins, because you have to try to buy scale for the most common denominator, which is sometimes you're overpaying then for when that's not in use. And then lastly, the more you have to do to manage your pipelines, the harder it becomes. And so where you can, take more of that sort of schema on write approach and do schema on read instead, that's incredibly helpful in sort of managing this this application and being able to do more with less. So let's look at what this reference architecture looks like. So we start with our multi-cluster warehouse, which can do fast analytical queries. I can change the size of the warehouse to get faster queries. I can set up multi-cluster warehouse to automatically clone itself when more users are on the system. And that allows me to handle both of my scalability needs without having to over provision my hardware. And then from there, I can also isolate workloads. So I can set up different compute clusters, different virtual warehouses for different workloads. So I can have ETL workloads that are writing into the data store at the same time. I've got users on the system querying from the data store, all without any kind of locks or dirty reads or any sort of lack of integrity in the data. I've got all sort of transactional integrity there. If I've got a NoSQL database as sort of the core of my application database, the ability to ingest that in its native JSON or semi-structured format, so that I don't have to worry about sort of changing models under the covers is hugely valuable. And then ultimately, I've got a rich set of both commercial and open source business intelligence or data visualization libraries that I can reach out to, and I can either make the decision to build the UI myself, or I can reach out to a commercial vendor to actually just sort of embed that capability right within my product. So at the end of the day, with all of these use cases, our customers are building all kinds of data applications, and these are just some of the companies that are building data applications. And again, some of these started with owning Snowflake already for their own internal use cases and realized that they could build data applications on top of Snowflake based on the data that they already had. Others thought of us because they ran into scalability with their sort of original design, their original sort of infrastructure, and moving to Snowflake was able to address those sort of scalability needs. So regardless, you should know that both customers large and small are building data applications on Snowflake, and they're doing that with a very rich ecosystem of data providers, tech company providers, SIs that can help with all steps of the process of building your application. So however much of this you want to do yourself versus offloading to third-party data providers or third-party tools or professional services companies to help you offload some of your development needs, there's a huge Snowflake ecosystem to handle your needs in building your application. So with that, you can go over to developer.snowflake.com and build any or look at the sort of build use cases that we have, as well as start a trial if you want to play around with Snowflake and see how it could be part of your application infrastructure. That is my presentation. Thanks for listening. Let's kind of jump over to the Q&A. Okay, so it looks like someone wants me to explain a little bit more about the sort of ingestion of semi-structured data and how we do that and what the benefits are there. So in, if you think about a traditional relational database, you have to define table DDL, and that table DDL defines every column and its data type. And when you define a table, the data needs to stay fairly consistent across the structure of the table, meaning each row generally has each attribute available. If it's a fairly dense table, sure, you might be able to set some columns as nullable, but ultimately at the end of the day, the data has a particular shape or schema, as we call it. Within Snowflake, we have one column data type that's called variant, and that variant, when you designate a column with that data type, what that allows you to do is load semi-structured data, load arrays of data into that column without defining a bunch of attributes and their data type definitions. And as that data is ingested in Snowflake, we will actually parse and columnarize all of the attributes behind the scenes, many levels deep, and at incredibly large scales. And so what you can do then is, once the data is in that format, we give you a special SQL syntax that allows you to interrogate the data so that you can see, sort of what all the attributes are that are out there, as well as then write a very simple SQL statement on top of that semi-structured data that allows you to flatten the data into a standard tabular format or a standard query output. And so what this allows you to do is what some of our customers do, they'll ingest that data in that semi-structured format. They'll put views right on top of those ingestion tables, and that immediately allows their developers and or users to start working with that data in a more structured way. Okay, so I see another question around the multi-cluster compute and how that works. So when you define compute in Snowflake, and there's no limit to how much compute you can define. Every we call them virtual warehouses in Snowflake. It has a simple configuration screen. And you effectively, fill out that configuration screen, you hit OK, and now you have a compute defined. At that point, it's typically shut off, and you can have it either turn on automatically, or you can, manually choose to start it. But ultimately, when you configure it, there's two fields that you are able to designate called minimum and maximum cluster. Obviously, you could set both of those to 1, and the shape of the compute will never change. It will never horizontally scale. It'll just always run one copy of itself. But if you set the min to 1 and the max to something like 5 or 7 or 4 or whatever number you want to pick, what will happen is it'll start at 1, and as more queries come into the system, we have algorithms behind the scenes that will sort of automatically detect, hey, there's load on the system. We need to spin up additional copies of this virtual warehouse and load balance the queries against or across them. Again, you don't have to manage any of this. You don't have to build any of this. It's just automatically done. And so that demand will dictate that we spin up to your maximum. We won't go above your maximum. And then as that demand goes away, as users log off the system or aren't running queries actively, we'll automatically suspend those copies so that you're not being billed for them unnecessarily. So all of that sort of expansion and contraction, as well as load balancing across the different clusters in a multi-cluster warehouse, is all done out of the box in Snowflake. You don't have to do any sort of manual build of that whatsoever. And it's a great feature, especially in some of our embedded analytics use cases, as well as some of our other data application use cases. Not having to sort of build all that yourself is hugely valuable. Next question is kind of going against the storage. So the question is around sort of duplication of storage. And so yes, I just want to call out that, so as you ingest data into Snowflake, we are creating new files behind the scenes, unless you're using our external table feature, which I talked about before, which sort of points back to your files. When you ingest data into Snowflake, you are creating new files. We have our own file format under the covers. So instead of using something like Avro or Parquet or Orc, we ingest those and convert them into our own file format that we invented, that we have patents on, that is highly performant, highly compressed. It's columnarized, vectorized, and is incredibly efficient. So you are, sort of incurring a duplication of storage costs there. But the good news is it's at a very cheap rate. And so where in the past, I can remember, working in environments where we were hypercritical about, how much storage we were taking up, because we had such precious limits on our storage. And if we wanted to increase our storage, it meant also increasing, how many cores we were running, increasing the software licenses of the databases, buying all new servers, et cetera. And so, you know, it was really challenging to you know, effectively say we wanted more space, because it wasn't just as simple as asking for more space. Where in Snowflake, that is the case. You can just ask for more space and pay a very cheap rate for compressed data, to the point where we have customers that are storing petabytes within their Snowflake account, and doing so very economically. So just to kind of point that out. Okay, that looks like it's the end of our questions. I want to thank everybody for attending today. Appreciate your time, and I'll pass it back over to DZone.
Awesome. Thank you, Kevin, for that wonderful presentation. And DZone would also like to thank Snowflake for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Thank you and have a great day.